Hello everyone, today we'll talk about the problem subarray products less than k. We're given an array of integers and an integer k, and we have to return the number of contiguous subarrays where the product of all the elements within this subarray is strictly less than k. And the first and most important thing you should be asking or wondering is about what values specifically those numbers in nums can take. And the thing that will make our solution simpler is the fact that nums of a is guaranteed to be between 1 and 1000. Especially this first part is important because it means that those numbers are positive. Now, why do you think that's important? The answer is that when we have positive numbers, when we add another number to our given subarray, let's say, then the product can only stay the same if that number is 1, or increase if that number is greater than 1, but nothing crazier can happen. In particular, it cannot decrease. So, when we have this situation, what we are guaranteed is that when we have a correct subarray, where the product is not too big, then every subarray of this subarray is also correct. And when we have this situation, what we can use is what is called the two-pointer technique or sliding window technique in order to quickly count all these subarrays. So this is a standard optimization strategy where typically we would do an O of n squared solution that just goes through all the contiguous subarrays, because of course they are defined by their left end and the right end, and there are about n squared of them when n is the size of the array. But since we know that we can actually, for instance, for every left end, we can find the furthest right end that still creates a correct subarray. And we can just use a little bit of math to calculate the number of subarrays of that subarray that we have to add to our result. So, let's see this in an example. So, for instance, let's say we have a 1, a 2, a 3, a 2, and a 4. And let's say that our target is, well, why not a 5? So we can see first that we start at 1. And what we have here is product of 1, product of 2, product of 6. And now product of 6 is already too much. So we can now take the length of this previous correct subarray, and we can calculate the number of subarrays that can be created starting at 1, and that is of course 1 by itself and 1, 2. So now we have plus 2 to our res, and now we have to move our 1 to the right and keep moving it until our result becomes less than 5. So we move it to the right, we still have 6. We move it to the right, and now our product is 3. That's alright, so we keep pushing the pointer. Now we have a 2, our product is 6, so it's too big. We see now that there is only one possible subarray starting at our current left vertex, so we add 1 to our result, and we push it until our product becomes again less than 5. We get a 3, 6 divided by 3 is 2, that's okay. We push our right pointer, we find a 4, so we have an 8, that's too much. We see there is only subarray of length 1, so we add plus 1 to our result. We push our left end forward, so now here we are at the 4. Now our left pointer has nowhere left to go, so everything that we have here would also be a correct subarray, so we also add 1 to the result. So result is equal to 5 as it turns out. Now, we also want to think about what happens if k is quite small, because we can see that k can be 0 up to 1 million. 1 million is not bad. What about the 0? Well, if k is equal to 0, the answer is obviously 0, because any product cannot be less than 1. In particular, any empty subarray will typically assume that it has product 1. But that doesn't really matter, since even if k is equal to 1, since we are being asked for strictly less than k, then it is impossible to get strictly less than 1 in any subarray. So we can just look at it and either claim that if k is less than 2, then the answer is 0, which is always correct. Or when we are pushing our bounds, we can make sure that the left end doesn't go to the right of the right end. And so when we start to add our result, like here and here, we will add 0 possibilities. So there are two ways of dealing with this problem. And finally, let's look at the code. Here, I'm checking if k is less than 2 to return 0. Later, I can assume that k is at least 2, which makes it a little bit simpler. We maintain our current product, which starts at 1. Here I is the left end, j is the right end. We do not want the right end to go past the end of the array. And in each step, we push the right end once to the right, and we multiply our current product by it. Now, for as long as this current product is too big, we push our left end 1 to the right and divide our current product by its value. And when we stop doing it, then that means that currently we have a correct subarray, and we add all these subarrays that begin at I to our result. And of course, then we return the result, and that's it.